welcome all to another amazing session with Dr. Sidhu, who is a certified and licensed AP chemistry teacher. Today, we are going to continue with our topic of measurements and calculations with Dr. Sidhu. So, Dr. Sidhu, how are you today?
Hi, Komal. It's so nice to see you again. I'm very fantastic. Thank you.
So let's move forward, Dr. Sidhu. So please tell us about the metric system for measuring length, volume, and mass.
Yes, okay. So we were talking about measurements in our last session, that measurements are really very important. And we talked about the metric system and the English system of measuring the data. So today, in a very brief way, I'll talk about the measurement of mass, length, and volume. So first is about mass. What do you mean by mass? Mass is the amount which is contained in some matter. So that is known as the mass. In science, we measure mass by using kilogram. So kilogram is the SI unit for mass. And now we need to remember that how kilogram is related to grams. Like 1 kilogram is 1,000 grams. Like 1 gram is 1,000 milligrams. So these are the various units: kilograms, grams, milligrams. So these are the units for mass. And in labs, in chemistry labs, which device is used to measure mass? That is the weighing balance. Okay, so because there is a spring balance, but here this is the weighing balance by which we measure the mass of the various compounds or substances. Next, let's come to the length. For measuring length, usually we use a ruler. That's the device which we use. And what are the units which are used in chemistry? That is meters. Meter is the SI unit for measuring the length. But yes, the higher unit is like kilometers. So again, we need to understand that what is the relation between kilometers and meters. So 1 kilometer is 1,000 meters. Similarly, 1 meter is 100 centimeters. These are very important because we have to do the like dimensional analysis. We have to convert the units when we are doing the calculations. So we need to know the relation, that how kilometers and meters are related, how meters and centimeters are related. So it's very important. And next is about the volume. So what is volume? It is the in 3D space, that how much of the space is occupied by any material, that is known as the volume of the substance. And it is measured in unit of liters. So 1 liter is 10 to the power of -3 meter cubes. And 1 liter is also equal to 1,000 milliliters. 1 milliliter is equal to 1 centimeter cube. So we can say that 1 liter is also equal to 1,000 centimeter cube. 1 liter is also equal to 1 decimeter cube. So you see, again, the relation between the different units is very, very important. And in chemistry lab, to measure volume, we use graduated cylinders to measure the volume of various solutions.
These are very important things. So let's move with the continuity as well. Then how uncertainty is in a measurement arises?
Yes, very, very important concept is about the uncertainty. You see, life is uncertain, right? So similarly, this concept of uncertainty is very important. How it is related in measurement. Look, when we measure something by counting, we get the exact number. Like, for example, if I ask you, count these fingers, how many fingers these are? Of course, you will tell you will tell that these are 4 fingers. So counting is an exact number, like 1, 2, 3, 4, this exact number. But when we do measurement by using any device, maybe we are using a ruler or a graduated cylinder, then there is uncertainty in the measurement. And the measurement also depends upon the sophistication of the measuring device. Like, for example, this is the pencil and I want to measure the length of this pencil, and this is the ruler. So if I ask one of my students to measure the length of this in centimeters, so okay, we will try like this. And here I go. Okay, let me start with the centimeters. Yeah. So because this is centimeter, this is inches part. So here I can see it is 14.8. And if the another student will measure, of course, he will say, okay, I think it is 14.9. It means the length of this pencil is in between 14.8 centimeters and 14.9 centimeters, right? And now if we just do the visual estimation that between 14.8 and 14.9 there are 10 divisions, and the nib of this pointer, the nib of this pencil, if I say it is basically 14.85, and the other student can say, no, I think it is 14.86. So if there is a third student, he can say, I think it is 14.87. So what I want to tell you is that 14.8, it remains same for all the students. If we have 5 students, so one student is saying, no, it is 14.84. The other student is saying 14.85 centimeter, then 14.86 centimeter, 14.87 centimeter, 14.88 centimeter. So you see, always those 3 numbers, digits, like 14.8, it remains the same. Only the last number, it differs, right? So that last number is actually uncertain digit. Got it? So it is because we are doing the visual estimation of that. So that the last number is always uncertain number, uncertain digit. So this is the way the uncertainty arises in the measurements when we are using the devices like ruler or graduated cylinders.
So while we're talking about measurements, anything special you want to talk about the concept of measurement to our viewers?
Yes, yeah. For the measurement part, look, measurement lies at the heart of doing science. You see, we obtain the data for formulating the laws and various theories by doing various measurements. Like, it is because of the measurement we are able to figure out how safe that water is which we are drinking, whether we are anemic or not, whether the gasoline which we are filling in our car from filling station is up to the mark. So it is because of the measuring devices. Like, for example, these days, basically, no doubt we are still using the common devices these days to measure the various, doing the various measurements. But now we are having more sophisticated devices also for the measurement. Like, for example, there are oxygen sensors which are used in automobile engines, which can actually we can estimate the amount of the oxygen in the automobile engine. Similarly, let us consider one another example about the safety in airlines. How we are able to determine very accurately and conveniently whether any luggage contains any explosive material or not. It is that these days scientists have developed a screening procedure where they bombard the luggage with high energy particles, and those particles, when they are bombarded with the material inside the luggage, it emits some radiations which are characteristic of the material which is present in the luggage. So that way we are able to figure out that luggage which contains some kind of a material which is high in nitrogen, because you see, the explosives basically contain more of the nitrogen. The explosives are basically nitrogen based. So that way we are able to figure out whether that luggage contains any explosive material or not. And these days, one very interesting thing is that scientists have started analyzing the natural world also maybe for using the techniques to generate sophisticated devices for measurement, like the sensory hair from, like, I'll see one thing, like, no, sensory hair from Hawaiian red swimming crab. It is connected to the electrical signal, and it is used to measure the hormones levels up to the level of 10 to the power of negative 8 grams per liter. You see, this much of the small amount we are able to detect because we are using the sensory hair of that crab and the tissue of the pineapple cork that is used to measure the trace amount of the hydrogen peroxide present in the sample. But again, I tell you one thing. These types of advances in measuring devices have led to the unexpected problems in our day-to-day life. Because now we are able to detect even the trace amount of something which is present in our food or drinking water. And it scares us that whether this material, this trace amount, because we are able to now detect it. It was always present there. And we were not able to detect that, then that time we were fine because we were okay with that because we never knew that that material is present there. But now we know that our drinking water, our food contains that. So how do we know whether that matter, that material is dangerous or whether it is benign? And what do we do about that? How can we solve that? So that is a very major issue. So you see the rapid advances in the sophisticated instruments, the devices, it is very complicated, you know, when it comes to the exact measurement of the various material present in our food or drinking water.
Thank you so much, Dr. Sidhu, for your valuable input in the important topic of measurements. I hope everybody is getting benefit from these sessions, and we all are going to hold these sessions in future as well for your benefit and for your information as well. Please like and subscribe to Sidhu's Academy on YouTube. This is Komal Seth from Art and Media signing off.